Welcome to the lesson on operations with mixed numbers. In this lesson, we will describe the four basic operations and how we can apply them to mixed numbers and how we can solve problems with this. To define this simply, we understand that the operations can all be applied to mixed numbers assuming that certain rules are met. And of course, attaining and understanding those certain rules is what will help make it successful. Let's think about our very first two mixed numbers. So I have 2 and 1/4 and 1 and 2/3. These two numbers, I might think about adding them first. Of course, I could subtract and multiply. So I imagine viewing them as 2 wholes and a fourth, and then 1 whole and 2/3. How do I combine these? The whole numbers, of course, can be added, but the fractions is what makes it a little bit difficult. In order to help us simplify this, the basic process behind this would be to convert both of those mixed numbers by using improper fractions. So taking both of my mixed numbers, I'll convert them to improper fractions and see if I can add them, multiply them, and what operations I can apply. So remembering this process, I times the 4 by the 2 and add the 1 to get 9 as my new numerator, putting that over 4. And I'll add a 3 times the 1 plus a 2, which will give me 5 as my new numerator here. And of course, I'll keep my old denominator of 3, giving me an improper fraction of 5/3. Now I can't add these because my denominators are different, so I can convert to solve this problem, but at the current moment I can go ahead and multiply them to prove that with improper fractions I can ultimately find a solution. 9 times 5 will be 45, and 4 times 3 will be 12, so 45/12 will be the final answer of the product between both of those. If I wanted to add them, if I wanted to subtract them, I would again remember my rules of common denominators, that being finding the least common multiple and the greatest common factor of many of these fractions in order to continue with my operations. But let's take a look at another clear-cut example. Let's take a look at how I actually would add 1 and 4/5 and 3 and 2/4. Different denominators, different fractions, different whole numbers across the board that I would need to convert. Convert this to an improper fraction. 5 times 1 plus 4, 9/5. 4 times 3 plus 2, 14/4. Now, like I had before, I have two different denominators. Well, the least common multiple of 5 and 4 is 20, so that'll be my new denominator for each fraction. And how do I get to 20 from 5? I times by 4. So 9 times 4 is 36. 4 times 5 is 20, so 14 times 5 is 70. Now I can add. 36 plus 70 is 106, with the same denominator of 20. This very big fraction can, of course, be reduced from here. So what number goes into both 106 and 20? I immediately can only think about 2, so I'm going to divide both the top by 2, 53, and the bottom by 2, 20, to give me 53/10. From here, I can convert this back to a mixed number. 10 into 53 5 times, 3 is the remainder, 5 and 3/10 would be the final answer as a mixed number. So what about division? What if I have two wholes and I want to find out how many times 3/3 will go into it? So imagining 2 and 1/3 being divided by 1 and 1/3. I can again use improper fractions. Multiply the 3 times the 2, adding the 1 gives me a 7/3 for my first one. And then multiplying the 3 times the 1 and adding a 1 will give me a 4 as my numerator over a 3 for my second one. Now remembering how to divide fractions, it's as easy as rewriting it again as 7/3 times 3/4, flipping the second fraction. Now I can multiply numerators, giving me 21, and multiply denominators, giving me 12. And of course I can convert this back to a final mixed number solution by saying 1, because 12 goes into 21 one time, and using the remainder 9 as the numerator. So our final mixed number answer would be 1 and 9/12. And of course, you could even reduce this down if you wanted to. The ultimate connection between the operations on mixed numbers essentially boils down to the fact that in many real-world applications, whole numbers can actually be very rare, and you'd have to end up utilizing fractions in order to be successful at math problems.